So we're now going to take a look at another question from the 2020 HSC Advanced Maths paper. So this is quite a long statistics question. So we're told a cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. We then get a whole bunch of information about a 20-day period. The scientists collected data. We get a box plot of temperature. We're told about the mean temperature, how it varies from the median. We're told about the total number of chirps counted over the total number of days. And then we are given a least squares regression as a function of temperature and the number of chirps. So we are told that the least squares regression line does pass through a point x bar, y bar, where x is the sample mean of temperature and y bar is the sample mean of chirp data. The question then asks us down the bottom, calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees. So temperature is 19 degrees, how many chirps? This is our question in this case. So we're just going to write that up the top. We're just going to leave it on this screen because it's a little easier. So first we need to find a value for b in the least squares regression line. So this is question 27. We were told y is equal to minus 10.6063 plus bx. We can use this least squares regression line in order to find the number of chirps when temperature is 19 because x is the temperature. But we don't have this b value, so we first need to find this b value. The question told us down the bottom that the line passes through the point x bar, y bar, where x is the sample mean of temperature, y bar is the sample mean of chirp data. And we can actually find both of these. So to find the x bar, the second dot point in the middle says the mean temperature in the data set is 0.525 degrees Celsius below the median temperature. The median temperature we can read off the box and whisker plot. So the median temperature, we're going to be subtracting 0.525. Well, the median temperature is 22 because that's the center of the box and whisker. Minus 0.525. This tells us that x bar, the mean of the temperature data, is going to be 21.475. So this is our first important piece of information. The next important piece of information is finding y bar. That's the sample mean of the chirp data. Well, we're actually told that the total number of chirps is 684, and this is done over 20 data points, 20 days. So we can just take an average. We can just say 684 divided by 20 gives us 34.2. And this tells us that the average number of chirps is about 34.2. So it should be 34.2, 34.2. So this is our next important piece of information. We're going to use these values, x bar and y bar, in our least squares regression line. We're going to plug x bar in as x, y bar in as y. Then we're going to solve this for b because b will be the only missing value. We can do this because the last sentence in the question tells us the least squares regression line passes through the point x bar, y bar. So we know that this is the case. So this gives us y bar 34.2 is equal to minus 10.6063 plus b times 21.475. So we'll add 10.6063 to both sides. 10.6063. This gives us 44.8063 is equal to 21.475 times b. Divide both sides by 21.475. This is going to cancel these, and this is going to give us b is equal to 2.0864 ... Now this b value, we're just going to cut off at a certain number of decimals because we're just calculating a numerical estimate anyway. So we might present this as 2.086 The next digit after this 4 will be another 4, so we could also do 2.0864. These are all pretty much going to give us the same answer. The level of precision here needs to be not particularly high. So 2.0864, we'll say this is correct to 4 decimal places. This is the third piece of information. This completes our least squares line of best fit, because we now know that our line of best fit, lob, is y is minus 10.6063 plus 2.0864 times x. In the question, we were told if the temperature is 19, calculate the expected number of chirps. Well, y is the number of chirps, and x is the temperature. So we're just going to let x equal 19 and solve for y. So we've got y is equal to minus 10.6063 plus 2.0864 times 19. So when you plug this into the calculator, you get 29.036 ... The question very clearly tells us to the nearest value. So down the bottom here it says give your answer correct to the nearest whole number. So therefore y, which is the number of chirps, the expected number of chirps, is 29, and this is to the nearest whole. And this is the answer that we're after in this question. In terms of the marking is reasonably straightforward. You get 1 mark for identifying the median or one of the x bars and y bars. You get another mark for the other x bar or y bar. You get a third mark for subbing these into the regression equation and providing working. You get a fourth mark for then finding b. You then get a final mark for using your corrected least squares line of best fit in order to correctly identify y, and y will have to be rounded to the nearest whole. So this is a lot of marks for one question that really is just one continuous part. But this is a very common kind of statistics or quantitative modeling question. You see these a lot in many disciplines outside of mathematics. Quantitative modeling is a very useful thing to be able to do. So the HSC curriculum is trying to put an emphasis on that as well as the standard calculus concepts. It's trying to say this is another thing you might be required to do, and this requires lots of working on one thing, right? You're just focusing really on one type of equation to correct or identify that one equation. So you do see a lot of this in fields like econometrics or medical epidemiology, in social studies when you're doing statistical research, or edumetrics, education, quantitative analysis. All of these fields have this kind of these kinds of concepts and these kinds of questions in them.